Okay, excellent. So hello, everybody. Oh, hello. Good morning. That's too loud for too early in the morning. Move this over here. So my name is Steve Mushero, and I'm going to talk about scale, although I don't feel quite as big anymore after seeing those numbers. I don't have 100,000 hosts or a million triggers, but I have a few. And so I want to talk about what we're doing for large Zabbix installations. I think we do a lot of unusual things, even for our size. Have lots of interesting problems that we try to solve, and I want to talk about those. So I'm Steve. I'm from China. So we actually run large systems there. The Chinese have a large internet. We're an internet operation. I'll give you more details. So I want to talk about just all the exciting things we do there. So first, a word about numbers. This spring, when I wrote this presentation title, I said millions of hosts, or millions of items and thousands of hosts. We're not quite there yet. So we only have about half the hosts I thought. We have about 1,250 or 1,500 hosts and about 300,000 items. So I'm not quite to the millions yet, but I hope you're not too disappointed. I have lots of interesting things to share because I think we have lots of interesting scale-related issues, and we probably have the most heavily customized Zabbix system, or one of the most heavily customized in the world. So we're going to talk about that. We do have 75,000 triggers. We have 500 templates. We probably have 500 screens. 200 is kind of old. We have a bunch of proxies. We are a global operation, and we work on the internet. So for those of you that live in data centers and on nice, fast LANs and in very high or very low latency systems, I wish I had that environment. I don't. So some more numbers. As I said, we have 1,200 hosts. We have about 78,000 alerts and events per month. Most of these are false alerts or information. We have up to 1,000 actionable alerts per day in what we do, operate all over the world. So we have lots and lots of issues with unreachability. It's one of our huge pet peeves. We have lots of challenges communicating over the world at high data rates. So lots of different issues. So working very hard to reduce this. We have billions of data points in the database, which I'll talk about, and how we sort of scale, purge, and back that up. So what do? We are a managed service provider. So our job is to build and operate large-scale internet systems. So we run some of the world's largest e-commerce sites, games, mobile, apps, and so on. So our customers have about 250 million end users. So we sort of support systems that run the internet the size of Europe. So we have a fair number of 100 million user systems that are pretty sizable. So we do lots of different things, but in having 1,000 or 2,000 servers, I'm sure many of you have that, but it's one thing to have 1,000 servers of your own system and to have 1,000 servers across hundreds of customers, which is massive chaos and sets of challenges. So it's a very interesting area. Our customers use Zabbix, we use Zabbix, so it's a very dynamic environment. So we also run everything. We run hundreds of database servers. We run everything else. We run all types of databases, all types of PHP, Java, Node, Python, Ruby, all different databases, all different Java, all different search engines. If it exists on the internet, we run it. And therefore, we have to monitor it. So we have extended Zabbix to do monitoring of all these things. And everything I'm going to show you or talk about today, we're happy to share. So we have lots and lots of customizations, custom scripts, custom monitoring for all this stuff. And so anybody who wants this, we're happy to give it away to you and teach you how to use it, because hopefully make your life easier. So how do we do this? We have about 100 people, about half in operations. We have about 25 integrated systems. So we have also integrated Zabbix with our ticket systems, our contact systems, our communication systems. We have rule systems. We're adding time series databases. We have expert systems all tied into Zabbix and different systems. So tomorrow I'm giving a talk about Zabbix database. We do a lot of heavy database integration with Zabbix, so we have a lot of experience with that. Something that makes us a little unique is, I think a lot of you come from maybe financial systems or enterprise or other corporate environments where things don't change quickly. I think it's fair to say that most of our customers change most of their systems, if not every day, every week. So it's totally normal for people to add systems, add servers, add hardware, add services, change ports, shut things down, reboot randomly every hour. And so we have a very, very dynamic, chaotic system. And so that causes a lot of interesting issues. That's why we're heavy template users. And we always have to check ourselves, because we have to assume that Zabbix is misconfigured at least 10 or 20% of the time. because it doesn't know everything that's going on sort of in a very chaotic environment. So that's the Wild West. So I have Clint Eastwood here. So very dynamic and very interesting. So how do we use Zabbix in sort of large-scale system? So this is our core monitoring system. We've been huge Zabbix fans for 6 years. I'm not sure what version we started on, 1.4 or 1.6. And we evaluated everything else. The template system is magic for us. The security system is by far the best there is in terms of supporting what we do and what our customers do. The performance is really also impressive, of course. The distributed nature of Zabbix is very important to us because we work globally. We work in actually hundreds of locations. So we don't have 2 or 3 data centers. We probably have 200 data centers around Asia and the world, so that causes interesting issues. We have heavily modified Zabbix to receive data from other systems, and I'll talk about how we do that. And lots of automated, a lot of reporting. As you probably know, the Zabbix reports aren't so useful. So we've extended that, and again, we're happy to share dozens and dozens of reports and trends and configuration things with people. We have whole dashboards of just reporting data. We have about 100 full-time users, 100 real-time users, about 25 hardcore. So we place a lot of load on graphs and screens because we're constantly loading them at refresh rates across dozens and dozens of people and dashboards and monitors in the office and at our customers. So we place a pretty heavy load on the user interface and responsiveness of the system, which actually is pretty good. So this is hard to see a picture of part of our operations center where Zabbix is front and center. And other screens and pieces and custom parts. So anyway. So as I said, it's heavily changing. We have about 500 templates. We would die without the template system. There are some annoyances in how the templates work in the database, but from an end user perspective, they're great. We use them for every customer, for every subsystem, for every piece, and I'll talk more about that. But basically, new MySQL servers, new Apache servers, new so on, template-based. But remember, we have to support every version of MySQL in existence. We have to support every version of Java. We have to support every version of everything. And so how we do that in templates is colorful. And it creates this explosion of template operations. So we're trying to get down to less than 100 templates. That's kind of our goal. Right now, we tend to have people create too many templates for too many new things and then try to reconsolidate into sort of core usage. Java is a particularly evil for this. We have a very nice and powerful JMX system, which I'll talk about. But as you know, different versions of Tomcat, different Java apps, different servers are all different. Cisco switches are another fun game of that. So it creates this explosion of templates, and because we don't have any, we don't use template hierarchies, so we're still thinking about how best to improve that. Also, some of our largest template, the core Linux template, has 163 items. This runs on every server. The problem with this is this takes 5 to 15 minutes to update, because it has to touch every item or every item on every server. And so this is a quick way to lock up the system for 15 minutes is by touching this. And there also are some bugs in the user interface in our version that cause some fun with this. But we're looking at how to split this and how to, what is the right trade-off between macros, templates, splitting, all the items that you want. I think this is an interesting open question for us in our dynamic environment. So right now, Red Hat, Ubuntu, and other things are all in one template. We're probably going to split them. But this creates risk because then it's very easy to forget them. And as you upgrade servers and change things, it's easy to lose things. We also, I didn't mention, we run everywhere. We run on physical servers, private clouds. We run on all the world's global clouds. So we're on Rackspace, Amazon, several others. We're on half a dozen Chinese clouds. So all of these systems run all different versions of everything, including CentOS, of course, Red Hat, CSA, and so on. So how do you get templates that control all this, and how do you get logic? Very interesting over time to see more triggers and more logic to kind of support that. So SNMP, we do a lot of. The bulk feature that's coming in 2.4 would be really nice because that's a big problem today. We have agents on all the hosts, so we do not do simple checks. We do not do a lot of other things. So we do not run SNMP on hosts other than networking. We run agents everywhere. We run them in passive mode. That should be interested in some of your experiences in running big systems in active. And we do this for security because our Zabbix server is public. So it's on the internet. So we don't want thousands of hosts around the world, including all the hackers, to be able to attack it or reach it. So in our case, the Zabbix server and the proxies reach out item by item to the field all over the world. And this causes us some challenges because we already run maximum number of pollers. I think the number of processes on the Zabbix server is getting close to 2,000 because we max all the pollers of all types. And so we don't have a lot more capability there without going to proxies and other things which we'll talk about. But I'm not sure this is the best way to do it. I'd actually like to go to active, and we may do that to try to do things faster. We're also going to more proxies, which I'll talk about. But right now, we're 100% passive. We have lots of custom scripts, at least 25. This is where we have really extended sort of the items. Probably half our monitoring is with agent and sort of built-in things, and half is with these things. Again, we're happy to share these. We have really nice MySQL monitoring, so you can just add the key for any MySQL variable, any MySQL configuration option, so anything MySQL has, and it'll automatically get that from any version. Same with JMX, automatically get any JMX key from any running Java VM, of course in real time. So this is super nice to support templates and anything, to be able to do that with full security and everything. So we have really nice monitoring. We have monitoring for everything else that you can imagine, and we add more. We also have added ability to monitor Linux proc file system because we need to see things like swappiness, we need to see a TCP memory pressure, we need to see disk device queues, we need to see a lot of stuff that only the kernel has. So right now we've done this in scripts. Once we get to 2.4, we'll actually modify the agent. I have a list of about 100 upgrades for the agent that I want to fix things that annoy me or it doesn't do, so we'll start back adding these and feeding these back next year to get all this stuff. IO stat, which you really can't get that well right now, is critical to us. We have custom stuff for that. We'll be adding that to the agent also. VMstat. We have a dynamic RAID system that can read any common IBM, Dell, HP, and so on. RAID card status, and feeds that to Zabbix also. So we have a lot of this stuff. We also have a catch-all file system. You know, it's very nice. Now at Discovery you can find, I think, file systems. But again, customers are changing things all the time. So it's really easy for us to not be checking all the space on all the file systems. Happens every day. So we actually have a system that looks for the least free space of any mounted file system and feeds that as a string to Zabbix. And this has saved our butt hundreds and hundreds of times. So in our environment, this kind of thing is really critical. We also push data into Zabbix. One of the annoying issues is that the server will only accept data via the Zabbix sender from the proxy which hosts or manages that host. So if I have a server that's in Riga and its proxy is in London and the actual Zabbix server is in New York, I cannot send data to New York about that server. The Zabbix server will reject it. It wants to get data only from the proxy that controls that host. This is really annoying when you have a centralized system like our syslog server. So without this, we have to round trip the whole planet multiple times to get data into Zabbix. And of course, we lose data. So we modified the server so it'll accept data from anywhere. And this is really nice because now I can send data directly to the Zabbix server from many of my other types of monitoring systems that I have. And this is like a 20-line patch, which we can share. So it's very nice. We use this for syslog. So all of our syslog is centralized. We run SEC. This is the only way to catch OOM errors. This is the only way to catch file system corruption problems, things like this, seg faults. So stuff like this is really powerful. And the reality is the Zabbix log monitor isn't really good enough, at least for us to do this sort of globally. But maybe. We also have a distributed web monitor that I'll talk about. We don't use the Zabbix web checks at the moment. We used to. I'm glad to see there's new features coming. The killer feature we need is reason why it fails. Right now, I can't get that. And it's not in the database in a useful way. So I can't tell if I have a DNS failure or a timeout or a status code failure. We have timeouts every day, thousands. But that's very different than if I get a 503 error when I expect a 200. If I get a 503 error, that's a high priority error. I want to deal with it right away. If I have a timeout, I want to retry, and I want to come back and try that in 15 minutes and so on. With the built-in system, I can't do that. So we actually built a globally distributed web system. Of course, in 2.2, I can do distributed on Zabbix, but I can't do that on 1.8. So right now, that actually extracts data from Zabbix in real time, builds web checks, runs them in parallel, and pushes data back into the system of real-time stats. It also tells me the response time and all these things that I can't get out of the current checks. So that's on my list of things that I want to get improved. And later, we're going to add multi-node stuff with voting, because even with single-point checks, it's not really good enough for us when we're checking things around the world. I can't get the sensitivity down to tell when a server crashes within 1 or 2 minutes or 30 seconds when I'm polling across the planet. You might be able to do this in your data center, but I can't do it around the world. So we're trying to find ways to check really quickly thousands of servers and report, downtime in 10 seconds, 15 seconds. To do that, I need to be distributed, I need to be able to vote, I need to do a bunch of stuff. So we're working on that. So, other things we use heavily, screens. We have hundreds, huge screen fans. However, we don't have a great way to automatically set them up. We build new systems almost every day. So every couple days. So I have new customers, new screens all the time. These may be 1 server, 10 server, 50 servers. And so it's very hard for us to build screens that are useful. And our engineers get frustrated with this. So we're building a new automated system that will automatically lay out screens and maps based on the types of servers from that customer. So it knows that anything with a web server in the name goes on one layer, one type of graph. And these are the types of graphs to show. Database servers have this type of graph or this type of map. And then you can drag and drop, but it'll do all the hard work for you. So we'll have that in the next couple of months. And that'll make our life much, much easier to sort of auto lay out this kind of stuff. And then we use the API for this. Maps, the same problem. The maps are pretty good. I wish we could put graphs on them, but really painful to set up and to edit at any volume. So we're going to automate that. IT services reports, we actually don't use. Reporting is really not useful to us. Discovery, I'm interested in hearing how other people are using that and how we could use that, especially for file systems. So our experience in this, and I have more detail here, overall is great. I mean, Zabbix runs our business, and so we are incredibly dependent upon it. We have lots of little frustrations and lots of lists of improvements. It's actually quite long. And a lot of things. Proxies I'm going to talk about kill us. False alerts kill us, and other things. And I'm not sure we're going to be the world's biggest user anytime soon, but I think so. By the end of next year or the year after, I think we'll be probably the world's largest user, at least by some metric. So some issues and improvement areas that we want to tackle. Time checks are a huge problem for us, essentially useless. And because we fought with this for months, and we finally figured out how they're processed. This is checking the fuzzy time of the host. So I want to make sure that all the servers in our system are all accurate to time, right? We have concluded that we cannot do this because the delays with the proxies and the way the DB syncers work cause too much latency in the check. The check is done by the server when it saves the data into the database. The problem is trying to compare the time it collected from the server many, many minutes before, potentially. And so we have endless false alerts on time checks. And so we've given up on this right now. We actually have a custom set of SQL reports that average and amortize the data over the last day to try to tell us which of our servers are out of sync. This, again, is not a problem in LANs and other things, but it's a big problem globally. The time system really doesn't work for us. Unreachable also is an issue. I've studied the Zabbix unreachable system and other things for a long time. I still don't understand it. And what's unreachable and when and why and which pollers are used. So maybe you guys can help me with that. Huge number of agent things we want to improve for Linux. IOStat devices. Linux memory RSS is a critical one that isn't useful today. We also would like to have a feature for latching. I don't know if this causes problems with you, but for us, we're always trying to catch things that change. Like someone changed a file. I can use hysteresis to do that, but when I'm a 24/7 monitor operation, I don't know if someone has seen it. I can't acknowledge it. Zabbix today has no way to hold an alert on the screen or on the system until it's manually acknowledged. It goes away automatically. And I can build in hysteresis for an hour, a day, a week, but this pollutes the system. And I don't have a good solution for this yet, but it drives me crazy. So some scale issues. I'm sure you're interested in scale. I'll talk about a bunch of these. As I mentioned, we have Linux template size issues. Database size. For us, the biggest issue is database I/O. We are still on physical disks. We're going to SSD this month. As soon as I can get the 2.0 upgrade to work, which still doesn't, for me, things timing out and so on. So quick issue on architecture. Our system is set up. We have a central Zabbix server in Shanghai, in China, and we have 10 proxies in 5 countries that sort of feed data to us. Our goal long-term is to be 100% proxy-based, because only that way can we do proper multi-country failover. Today, all of our hosts are locked down by IP tables and firewalls to the Zabbix public IP in Shanghai. So for me to move that means touching thousands of machines around the world. And So what we want to do is put it all on proxies. Then I can move the server, and all I have to update are my 10 or 20 proxies. So it becomes a much easier operation. So I can do HA, of course, in the data center and have a share the public IP, but I want to have different Zabbix servers around the world. So this is an issue for us. Proxies are sort of all over the place. Our core system actually runs on one server. Actually, it runs on I'll talk about hardware in a second. It runs on a very powerful Dell server, a lot of memory, and so on. We run this in VMs, private cloud. We've had no problems with this. It runs extremely well, and we've gradually scaled up over time. So the hardware requirements to us haven't been a big issue other than disk I/O. So here's some hardware history for us. We started on old, very small Dell machines. We're sort of down into the middle now, and our new Dell 420 is coming up this year, going to SSDs and probably 256 or 512 gigabytes of RAM, because we really need to get our database more in memory. Bottleneck is still I/O. We're sort of, our happy sweet spot is going to be a server with 500 gig of RAM and probably a terabyte of SSD. That will operate the way we want. So we have a ways to go. But this is really not that hard a hardware. This has now become quite cheap for fairly large scale systems. So. Database details, we run on Percona 5.5, heavily optimized with sort of all Percona best practices and all that sort of thing. We're about 200 gig in size now, growing to a terabyte in the next 6-8 months, so fairly sizable. Our backups take about 8 hours, including compression and all that. This is a problem, and I'm going to talk about the housekeeper here in a minute. But we've got about 2 billion rows in the history system. This is large for some people, not so much for others. That's sort of where we are at the moment. We've got sort of 48 to 96 gig of RAM in the server for InnoDB. So this is where we're running at the moment. And the database load is actually quite low and runs really well. We're doing between 500 and 1,000 new values per second. So compared to the 28,000 that like they had before, that's not very many. But and we actually work to keep that down. So we will start trimming things, changing intervals to keep that under 1,000, just for our own sanity and our own data growth. But that's where we are at the moment. So the actual Zabbix server config is really nothing special other than we have maxed out all the polars. Because again, our polars are reaching out long distances around the world, both on the server and on the proxy. So our Zabbix busy polar percentage runs in the 80–90% all the time. And we are extremely thankful that some of the latest versions have that data. I really wish I had it on proxies. As I mentioned, the DB sync is part of the challenge. It's slow for us. So what happens, we didn't realize this till recently, but triggers are evaluated when the data is saved in the database, not when the polar retrieves the data. I believe I'm correct on that. I hunted the source code pretty heavily. So if things are saving very quickly, it's not a big deal. But we have lag because our disks are slow sometimes. We may have 1, 2, 5-minute lag between when the polar gets the data from the field, queues it in memory in the Zabbix server, and when it gets written to the database. The trigger is evaluated when it gets written to the database. It's done by the DB syncer, which was somewhat surprising to discover. So you just have to be aware of that, because when you're trying to process triggers very quickly, they're not processed when you think they are. But the system is very, very quick. We have some cases I'll talk about proxies when they get stuck. But we've seen situations where a proxy will send 25,000 or 50,000 new values, and the server will accept those in 5 or 10 seconds, sometimes 2 or 3 seconds. So Zabbix server ability to take inbound new items is extremely high, which is extremely impressive. So that's where we are with that. So the housekeeper. Many of you probably have turned your housekeeper off. The current practice in 1.8, and I guess coming back in 2.2.2.4, is to shard the database or to partition the table. And I understand there were problems with that in 2.0, so we didn't do it. We wish we had, but today we run the standard vanilla housekeeping system. So we've got about 2 billion rows in the tables. The housekeeper kills about 7 million each time. The problem with this is the housekeeper needs to read the data randomly to do it, because it cycles through the events one by one. Sorry, it cycles through the items one by one to delete them. So you have heavy random reads. Our housekeeper, as of this morning, takes 5 hours to run. And if it runs during backup time, takes forever. So we've actually modified the server so that we can schedule the housekeeper. So today, our housekeeper only runs during the day and does not run at night when backups run. And so we've modified how it sort of interacts with that. Reality is we need to go to database partitioning. The problem when you do that is you lose control of per item storage. I can't keep certain things for 30 days, 90 days, 1 year, and other things for only 2 weeks. You have to decide that all my data is only going to be kept for 6 months. So there's some trade-off here. We'll see how SSDs work with this, but the housekeeper is really interesting. And so anyway, so proxies. We love proxies, again, because they save us a lot of time. They have much better performance. They help us a lot in our distributed systems. They help us on customers' sites. They generally work really well, except when they don't. And so the problem we have, and we're in version 1.8, and we hope this is going to get better, but there's something strange in the network handling of the proxy. And so what happens is, if you have packet loss between the proxy and the Zabbix server, the proxy will lock up. It will stop sending data. And all 1.8 versions do this. And we're not sure why. And you have to restart the proxy. So it will go from sending 1,000 values a second or 500 values a second to 100 to 50 to 5 to 2. And it'll stay that way for an hour, even after the network has recovered. Restart the server, restart the proxy, and it'll send 10,000 in 15 seconds. So there's something in the way that it interacts with TCP that we're hoping gets better, and maybe there's some other wisdom. And those of you that are running 2,000 proxies, I would love to hear this, because this drives us crazy all over the world. So we actually have to work around this. We have auto restart processes. We have auto reroute processes so that we can reroute traffic around the world to get the best latency to keep the proxy operating. We're also adding a GUI to the proxy, which we'll share if people want, to actually show the queues. There's not a lot of good proxy monitoring right now, basically none. That's something I'd like to see, because right now you can monitor lots of nice stats inside a Zabbix server, but you can't monitor anything inside the proxy. And I'm not sure if you can do a custom agent or something, but it'd be nice to be able to see the polars, all this type of stats, because the proxy code and the server code are basically the same. If you look at the Zabbix source code, everything is shared, but we can't monitor anything in the proxy, so we'd like to be able to do that. But it uses a MySQL database or a SQLite database, so you can monitor the queues. So we have a global queue monitoring system, so we can track how all the proxies are doing. We have maps that show all the queues, all the queue latency on all the proxies globally. And so this is really nice. We have command line Python tools that can show and reset the queue, and then also can see how the proxies are doing. So those of you that are using a lot of proxies, this might be useful, because they really are nice. When they work properly, they're great. And they reduce the load, they improve security, they do lots of stuff, but they have issues. So we're hoping to see that much better in 2x. So customization, we have done a lot, and we plan on doing a lot more. We've changed the dashboard a lot. We use this every day. It's on all of our screens. We've mostly changed columns, colors, and integrations. So for example, when you get an alert there's something wrong on a server, if somebody's logged into that server right now, the color changes. And you can pop up a list of who's logged in and when they logged in and why, and under what ticket number. Things like this. Ties to our ticket system. We can see the current ticket status. We can see all the emails back and forth, notifications to the customer. So the Zabbix dashboard becomes a much more of a dashboardy type of thing, where I can really see what's going on. Because remember, again, it's complete chaos. You've got hundreds of customers and 100 employees working on all these servers all the time. It's extremely easy to get all kinds of weird, strange things. And we're integrating that more and more. So that's a lot of things. So we've also changed the pop-up menus, I'll show you, to add a lot more dynamic stuff, so we can create tickets directly from the Zabbix menu. We fixed the ping system, which I think is sort of unusable the way it is, and so on. We're actually adding, just this month, a rule-based priority system. So we're actually overhauling the dashboard this month to do again, we get thousands of alerts per day, right? So how do you know what's real? How do you figure out what's important across different types of customers? So we have a new rule engine that runs every few minutes that processes the events, processes the triggers, looks at the history. Because if you get a new alert on, say, a high load average on a server that's never had that alert before, or not in the last month, that's important. On a server that gets a high load average alert every hour, not so important. So Zabbix today has no capability to think about that. No system does. So we're building the rule engines to do this. Look at history, look at customer type, look at distance, look at all types of things, and change the priority dynamically. So we have moved the priority from the trigger level to actually the event level. So we can dynamically scale priorities and responses based on this event, separate from that event, even though they're on the same template trigger. So it's a new thing for us. We're doing this in email too, so it's kind of cool. So we're adding more rule-based logic, and actually we split the dashboards. You have different priorities. Today they're all by color. We actually have multiple dashboard blocks that can show you as things move up and down, so that our support people can just focus on one part of the dashboard. If it's empty, nothing to do. If the system puts things there, something to do. Today it's kind of a big mess because there's lots of stuff going on. So this is an older picture, you kind of can't see very well. But there's different, we actually add the ticket number into the acknowledgements. We add the initials of who did it, so you can go find the right person and wring their neck. There's pop-ups and more things here. So actually the new version has case numbers and case history in here too. And we removed a lot of other stuff that we don't use. So we have about 6 versions of this for the customer, for us, for support, for different groups that have different features and functions. And one of those things also, but this is just a pop-up from here. We've changed this so you can view all the history, all the wiki systems, all the summaries, all the ticket history. This is very easy to change, so you can link into your own systems and use that. We've also changed how the URL system works. And normally on a trigger, of course, you can put a URL there, right, and say jump off to a wiki or to a knowledge base. The problem is that's generic, and it's per trigger, low disk space. We actually insert the host name and the system number and some other things in that URL in real time. So when you click on it and it jumps off to our procedure system, it can give us special customized procedures for that server. So it's a very small change in the UI, but it makes the whole procedure process wiki system very dynamic based on the history. So we use the Zabbix profile, which has like the serial number and all those things, and we put extra business information there, which ties you back to our other systems. And so you can just click on the UI and it takes you to the right place. That's pretty cool. You can auto-create tickets here. We also improved the graphs. First thing we did is put American dates on the graphs. Unfortunately, I'm American and I can't deal with the backwards European date thing. Or you probably have the same annoyance the other way. But we actually improved the dates a lot, and how we do the timeline. At the bottom, we show you the day of the week. Because I actually don't care about the date. The date's not that important to me as much as the day of the week. Did this happen yesterday? Last Friday, over the weekend? The current system doesn't show you that. And so, fortunately, it's a PHP string, it's a 2-minute change, but you can see now what day of the week things happened, and we have the times and so on. So I think it's a much better format. We also changed the fonts and so on. In the next version, once we upgrade, we will be doing a lot of graph work. I have dozens of improvements on graphs. We're going to bring a whole bunch of graphite features over. We're going to add annotations, probably, almost certainly, so you can annotate the graphs and say, what is this? And why is it here in a little pop-up bubble? That kind of stuff. More dynamic graphs, more other types of graph types. So we actually have a full-time Zabbix development team. We have 2 or 3 full-time people who work on changes on Zabbix, mostly on the front end and our other systems. So next year we'll be making a lot more improvements, of course feeding those back if you guys want to use them to things. But we use the graphs, I live in the graphs. But there's issues with the graphs. For example, scale, you've probably seen this, if you have a delta data point, so a data point that's really high in the graph and no fixed axis. So say you're monitoring bandwidth. If there's 1 minute of high bandwidth, everything else in the graph is really small. I need to be able to clip the graph, for example. Otherwise, I have scaling problems. A lot of these little things that are annoying that we're just going to fix. So, and it's just our graphs. These are other customizations I already talked about. The housekeeper I already talked about. The data sending. Pinging is another issue for us. Pinging works on kind of calling the ping system. That's great, except when you have servers in other data centers. There's no way to ping them to see if they're alive. So remember, we get unreachables at very high frequency. An unreachable, 98% of the time, is a network problem between me and the data center. But 2% of the problem, 2% of the time, the server is dead. We probably are going to build a separate, customized, high resolution heartbeat system for global use based on Python. So we're going to ping every 15 seconds or so UDP packets because I need better resolution than Zabbix can give me. But for right now, we live with this. And so the first thing support does when it gets an unreachable alert is pings the server. But if the server is in India someplace in a data center, it's behind a firewall. I can't ping it. So I have no way to get to it. And it's behind a proxy. So I can't even run Zabbix Git on it because the proxy is inside the system. So we actually customize this. So from the user interface, when you click on ping, it uses SSH and keys to call an SSH session on the right proxy in the right country to actually run Zabbix Git and get the version of the agent and make sure that the agent actually is up. directly. And if it's not, then it's an emergency, and we know the system's down. If it's up, we'll then wait 15 minutes, and we'll automate this. So for us, sort of globally, behind all proxies, behind all NATs, the current ping system really isn't good enough, and yet we have a lot of false alerts. And so we're going to build a whole new system for that. So, like I said, a lot of changes coming for 2.2. And SNMP, same problem. We do lots of database automation and reports. Tomorrow I'm going to talk about, I've got to talk tomorrow on database, just the database. It's called Loving the Zabbix Database. We love the Zabbix Database, really do. We have dozens and dozens of reports for all kinds of different things, mostly about configuration. We have a few for data. That's less interesting to us than configuration mistakes, problems, issues, latest data. Some of the changes in the 2.0 database have not been helpful for that. We actually have an auto ticket system. So when Zabbix, in most cases, based on rules, generates alerts, we can auto ticket. We actually do not use a notification or event system. It's too simple for us. So we actually have rule-based, customer-based, and so on, auto ticketer. But a lot of alerts go away. So if you ticket things, you start having thousands of tickets a day. And then load average or unreachable goes away. So we have an auto close system that comes behind and cleans up. So it says, oh, Zabbix saw this. It's a certain type of alert. It's not that important. We created a ticket, but the engineer hasn't gotten to it yet. Make it go away. And so we sort of auto-create tickets, and then we auto-clean them up kind of along the way. And those happen at sort of thousands of times a day. Kind of interesting. The rule-based system I already talked about, the auto-escalates all the rules. And the API in version 1.8 is pretty good, but it can't do everything we need for creating new hosts and new things, so we also do that in the database. So we have lots of database things. We haven't customized the database very much. We've mostly added some integration fields, so it's really been very few things to hack on it too much. We also have a whole new customer report system, and one thing hopefully Zabbix will add in the future, maybe 3.0. We'll have more reporting, more. I mean, it's great to have online stuff, but a lot of our customers want to have monthly reports. They want to see how things work. They want to see history. They don't really want to go clicking around the UI. So we actually have a whole system that dynamically lets you add customers, choose which graphs and which things, and then automatically by the API every month generate a nice PDF report, which it mails to them. And it can show them kind of what happened. There's still issues with this, but it's pretty cool. One of the challenges we have with that is it's still very host-based, right? If I add a template and I have servers, like for CPU, it's one graph per host. So I'll go to a template and I'll add a CPU item, I'll add a CPU graph. And then I'll have a screen and I'll go and add the graphs, right? But I have web server 1 has a CPU graph, web server 2 has a CPU graph, and so on. That's all automatic. It's all in the template, it's all beautiful, dynamic. But it isn't really very useful for a large system because I really want to see one graph with all the CPUs of all the hosts. That's easy to do, but it's 100% manual, and it's system by system. And that's a big problem for us because we're doing this every day. And so we're automating the ability to combine metrics and combine graphs on the server level and then add it to a screen and add it to the report. So we're very dynamic systems. This is really, really useful. We have lots of ad hoc SQL stuff, and we're going to be publishing a lot of these so that people can use them because some of the templating, some of the other stuff I'll talk about tomorrow, it's quite complicated to get the right types of hosts, understand all the template relationships and all the graph and data relationships. So we'll do that. So these are the type we call these safety reports, which is basically looking for mistakes because it's very, very easy, for example, to enable something on a template, disable it on the host, disable it on the template. And when you have dozens of people changing the system all the time, it's very easy to get things misconfigured and all of a sudden everything's disabled. And how do you find that? And how do you figure that out? So we have reports that cross-reference all this and look for all kinds of different things. Very easy to break things. So here's some examples of what we do for that. Items that aren't in the templates, missing groups, disabled items, things that are missing, URLs, wikis, conflicts, all that kind of thing. So, and we have dozens of these. So. Security real quick, at scale, we love the Zabbix security system for customers. It works really well because all I have to do is take this customer's servers, put them in a host group, give read-only permission to a customer user, and I'm done. Customer logs in, customer can see their own stuff. Near as I can tell, no other typical monitoring system has anywhere near that type of security feature. So this is really useful for us, and it scales up to hundreds or thousand users with no problem. So it's really good for customers. The problem we have with lots of users in lots of different places internally is the security system is not granular enough. It's either read or write. And if it's read-only, you can't see the trigger screens, and you can't see the trigger thing. So we have junior engineers who like to play with things, and like to break things, and like to change things, and cause problems on the system. There's no way to let them see the configuration without giving them read-write capability. So we've added extra screens that can show this. We have read-only trigger screens. In 2.2 or 2.4, whenever we get upgraded, we're probably going to try to add more features to the security system where we can control activity. You have read-write access, but only certain groups of people can change the triggers, this type of thing. We really need that functionality because we need to have a better way to control granularity. The audit system is great. There's really a great audit system. Unfortunately, the reports are useless. There's no way to figure out who changed what, where, whatever. So we've built an audit reporting system that can tell me what a certain person did in a day, who created this trigger, how this got touched, and all that. So it's complex in the database, but it's really useful. So run out of time. So a future for us, this Zabbix really is very good. We have a lot of ideas, a lot of future improvements, long lists of things. We're still small. So everything about this, we still have to scale this 10 times in the next couple of years. And then we need to scale it 10 times again. What are we going to do when we have 100,000 hosts and 1 million alerts a month? How are we going to manage this? How am I going to manage these drop-downs when I have, right now there's hundreds of host groups and thousands of servers. How do you find anything? So we're thinking a lot about how we're going to do that and how to help you guys do that. We're also thinking about how to go to more rule-based engines, how to go to more event-based. We probably are going to integrate a time series database into Zabbix next year, replace the history system. I'm not sure what we're going to use yet, but to do better and faster time correlation, we'll change the server for that. We're adding a lot of new agent features next year, new GUI stuff coming. Just think about how we're going to scale this up for our own use. Otherwise, we have to replace it. We don't want to replace it. So we're trying to think about all of this stuff. Hopefully, this will help some of you. Last slide. What it says, right? I mean, Zabbix really is great. It is the critical core system for our business. Lots of improvements. This is great. One of the reasons we'd like to stay on it is because Zabbix is changing. It didn't change that much, I think, early 1.6, early 1.8, but it's becoming more and more. Companies getting bigger. There's more people, more change, more you guys, more vibrant things, more features coming. Never fast enough for us, I think. But this really is, I think, the best system in the world. The most vibrant new stuff is coming. We're happy to be part of it and happy to hopefully contribute and add a lot of stuff in the next few years. And we're very happy to share everything to everybody. We're trying to figure out how to do that, how to publish this stuff, make it online, get our code back, all that kind of stuff, so the rest of you can use it. So happy to help. This is us. Thanks.
Thank you. My name is Eugene. Do you have a configuration management database? So CMDB. You speak about here earlier in the second slide. Configuration management database. I see these letters.
So we do. We are trying to build the world's most advanced CMDB that I hope to be able to give away next year. Our problem is that most CMDBs and most so we have two things. A little off topic though, but real quick is pushing configuration. So Puppet, Chef, all these build systems. They are great to build new servers if you know what you want and what you have and have a template. Our problem is most of our customers don't do that. They change everything on the server. So the system of record is the server, right? And so we have to try to figure out, what did you do? What is there? So we are actually building a system that completely reverse engineers every configuration point of every system on every server and dynamically tracks it. And so on a global basis, it can then re-push it and template and clone.
Okay, so maybe the right way is changing in CMDB by clients. So you can share your CMDB to clients.
Yeah, well, we'll share it. We'll open source it. But yes, so they can see who changed what where, and we get Zabbix alerts when they touch it. Because what happens is developers, third-party developers, for some random company will go in and change something and not tell us. And they'll change it on Web 1 but not Web 2. And then a week later, the system will start to melt down, and we can't figure out what happened. And we can check a file timestamp or something. Okay, someone touched that file. We actually have a log tracking system that knows when you log in and what you touched and all that kind of thing, but it's not that good. So I can tell now you touched this line of this configuration file, but I can also parse it. I can also do all the rules. I can look at our entire system base and say who's running best practices Nginx configure today, and I can run rule engines on that. And this doesn't exist in the whole world, as far as I know. So it's sort of like an ITIL CMDB, but another level or two up in power. So we're building that. So we'll give that away next year.
So on slide number 20, you said that you are using a virtualized environment for Zabbix server and database. What about database? Is it a hardware storage or it is also virtualized?
A database is also virtualized. So it's on very simple Zen-based sort of private cloud virtualization system.
So what type of storage are you using for Zabbix database?
So today it's on a set of RAID 10 SAS disks, and we are migrating this month to SSD.
Mm-hmm. So your experience to migrate to SSD too?
Well, we're doing it now. Yeah, we're having trouble with the 1.8 to 2.0 upgrade in the database. There's some issues that we're trying to work on. We're working on it for 2 or 3 months. I'm actually interested in people's upgrade experiences because we're still working through it.
Okay,
but yeah, we're going to SSD though, because the I/O is killing us.
We would like to know your results on this. Yeah. Thank you.
You said that you monitor servers all in the world. And how about secure communication between Zabbix proxy and Zabbix server, and Zabbix proxies and Zabbix agents? Because if the communication goes through the internet, there is Zabbix doesn't provide any any security for this communication.
Yeah, I know some people care about that. I don't care about that. Okay. For several reasons. One, we're already on the internet side of things, so we're not doing banking, we're not doing this type of thing. I mean, we have lots of other security issues. This is way down the list. If I can get my customers to stop running, PHP servers and Java servers as root, I'll be really happy with that. But the reality to me is, because we don't allow actions, so there's no remote actions. They're disabled by the agent. So, to us, someone going to steal some monitoring data is really not a big issue for us. And we do lock down everything, sort of who can communicate with who. So it's hard to see, other than sort of really, esoteric hacker type things, how that's an issue for us. And the performance challenges and other things. SSL would be nice, but way too slow if you're doing, like we are, passive connections. I mean, there's no way to do it. So we just don't care.
Yeah. Thank you.